Alright, hello everyone, Mr. Stevens here. This time with a new concept from statistics. I don't think many of you will have heard about quartiles before, but the good thing is that a lot of what we're going to be talking about today is very similar to some things we already know. We already know about range, as in the highest number minus the lowest number. The interquartile range is basically exactly the same as that. And we already know about the median. Quartiles are basically exactly the same as the median. So I think we already know how to do almost everything that we need to do today. It's just in a slightly different package to what we've seen it before. Let's jump in. Quartiles. All right, we know about the median. It's the number in the middle. What we probably don't know is that it is also technically called quartile 2. We will probably still call it the median, but it's important to know that it's technically quartile 2 because we have quartile 1 here and quartile 3. So how do we get quartile 1 and 3? Well, we have the median here in the middle, and then we take the numbers to the left of the median, and we find the middle of those, and that's quartile 1. And then we take the numbers to the right of the median, and we find the middle of those, and that's quartile 3. I would encourage you guys to take a second to write some form of this picture down under the heading quartiles so that you don't forget exactly what Q1 and Q3 mean. You can leave out my annotations, but some example like that, a list of numbers, identify Q1, Q2, and Q3. Alright, after you've written that down, we're going to write down the 5-number summary. This is reminding us what the 5-number summary is. It starts with the lowest value, and then it has the lower quartile, Q1, the median, Q2, the upper quartile, Q3, and then the highest value. This is pretty straightforward, but you're going to see this come up a lot in this lesson and the next one, so it's important to have it clear in our minds what it is. Alright, I'm going to do a quick example for you. The lowest value, we're finding the 5-number summary, sorry, I didn't say that, is 0. We don't know Q1 yet. We don't know Q2 yet. We don't know Q3 yet. Let's grab the highest value first. That's 10. Alright, now we'll do median. You have to start with median before you can find Q1 and Q3. So I'm going to cross off numbers. And the median is between 4 and 5. 4.5. Now the median is here, so we take all the numbers to the left of the median, and we find the median of those, which is in between 2 and 2. And then we take the numbers to the right of the median, and we find the median of those. And that is 7.5. If you're wondering, 7.5 is the average of 6 and 9. Alright, and the last thing we're asked to find is the interquartile range. Now, a couple of lessons ago, you guys were finding something called the range, which was the highest number minus the lowest number. You might be able to guess the interquartile range is just the highest quartile minus the lowest quartile. In this case, it's 5.5. Alright, let's have a go at doing that together. I'll get you guys to write this example down. I gave the question not in order, but in the interest of time, I've written it out here in order for us. We've got the lowest value is 12, and the highest is 52. And now let's do the quartiles. Crossing off from the ends, we end up with a median of 17 in between 16 and 18 here. Now we end up with a Q1 of 15, and we end up with a Q3 of 22. And then the interquartile range, we take the highest quartile, we minus the lowest quartile. The answer is 7. I think that's pretty straightforward. Basically, we're finding the median, and then we're finding the median of the lower half and the median of the higher half. That's what Q1 and Q3 are. Another new thing we have to deal with today are this thing called outliers. So I want everyone to write down under the heading outliers, basically these two lines. However, there is a mistake in this second one. That should be a plus. Outliers basically are parts of our data that are really far either above or below most of the other data. So we're going to be plugging in the numbers into these formulas, Q1, IQR, and Q3 and IQR, and we'll find out if a number is smaller than this top row, it's an outlier, or if it's bigger than this bottom row, it's also an outlier. I think the best way to see that is in an example, so let's do one right here. We're trying to identify the outlier of this data. We don't have to find Q1 and Q3 because they're already identified here for us. Q1 is 20, Q3 is 48. The interquartile range is 48 minus 20, which is 28. Right, so we need to grab those two formulas from the previous slide and plug in the numbers. So this ends up being 20 minus 1.5 times 28, negative 22. Now, what is this number telling us? This is telling us that if anything in our data is smaller than negative 22, it's an outlier. We don't have any negative numbers in our data, so we have no outliers at that end. Let's check the other end. This time we've got 48 plus 1.5 times 28, which ends up being 86. Now what this is telling us is any number bigger than 86 is an outlier. So in this question, 91 is an outlier. Now I want you guys to think about this for a sec. This kind of makes sense, right? If we look at all these numbers, the gap between each one is like 5 or 6 at the most. And then we get over here and we've got a jump of 30 to get to that last number. So it makes sense that if we sort of put dots on a number line for each of our bits of data, we would have a whole bunch of dots here all grouped together, and then all the way over here we would have 91. There's a massive gap here. So it kind of makes sense that that's an outlier. What these formulas enable us to do is to give a reason mathematically why that's an outlier. We don't just have to look at it and say, oh, that's a massive gap, so it must be an outlier. We can use this formula to say, this is the reason why it's an outlier. All right, example here for you guys to do that puts everything we've just done together. Have a go at this. Pause the video and I'll have solutions for you in a minute. All right, here we go. Solutions for this question. You've got the highest and lowest number, 1 and 18. That's fairly straightforward. You cross off from each end. The median here is 4. You've got Q1 there and Q3 there. We plug everything in the formula. We find an outlier is any number less than negative 3.25. We don't have any of those. 1 is our lowest number. Or anything bigger than 10.75. And here we see we have one number bigger than that, 18. Now, I haven't written down an answer for this question here, but I want to talk about it because we're going to get this kind of question a lot going forward in this lesson, but also in subsequent years, especially if you get into standard maths in the HSC. We have a whole bunch of data and we're going to be asked to explain what's happening. Can we give a possible reason why we have an outlier of 18 in this data? Well, this is where we go to the question. This is a group of people on a tour for 13 days, counting the number of geese they see. Why did on one day they see 18 when the most they saw on any other day was 7? I think maybe a plausible explanation is that on this particular day they maybe saw a whole flock, whereas on these other days they were seeing 1 or 2 birds at a time. That may seem like kind of a silly example, but it is really important for you to be able to read the question, think about the situation that's happening, and talk about it logically, give reasons why things are happening. It's a very important part of statistics. So if you have any problems with that in particular, but any of the stuff that we've looked at today, make sure you get in touch with your class teacher and ask for the help that you need. Otherwise, you can jump into the textbook and start doing your independent practice. Thanks, guys.